real, what I consider real three-step equations for this. Our main focus out of those 7 steps that we have is we need to bring our x's to one side and our numbers to the other side and then solve. So we're going to have multiple variables and multiple numbers while we're doing these questions. So for example, like this straight here, and I probably give away a little too much here. So I have x's on both sides here, and I have numbers on both sides as well. So I personally prefer to collect my x's on the left. So this is the term that I want to move to the other side. So by moving it, I have to do the inverse. So as it's a positive 3x, I'm going to subtract 3x from both sides. Notice as I'm doing it on both sides, I'm lining up the x's together here now. So I didn't put my 3x here, I deliberately lined it up with my 5x. By doing the opposites on this side, it will cancel. And on this side, I work out what I have. So 5x take away 3x is 2x. This plus 7, I just leave as it is. And this positive 11, I'm going to drop the positive sign, and I'm just going to keep it as 11, but you can still leave it as positive 11 if you like. The whole point of the last lesson was, once we know we can do a 2-step problem, a 3-step problem is just 1 step more. So these are exactly like the questions we talked about at the start of the lesson, but also in our very last lesson as well. So as we only have one term with x now, let's look what we're doing to it. It says add 7. So do the inverse, which is to subtract 7. Do that on both sides and work it out. That gives us 4. And then instead of timesing by 2, you can divide by 2. So all those previous lessons were really important because it's kind of like a new starting point. Once you do one new step today, you're at the same question you did last lesson. And same for today's lesson. It's going to be important that you know that 3-step equation, because next time when we do 4-step equations, I'm actually going to show one new step, and then you're going to be practicing those same 3 steps. So if you go into difficulty, make sure you ask for help, because otherwise the problems are just going to compound themselves because you're relying on previous skills as well. Let's look at one that's a lot more complicated here, mainly because I have negative signs here. So I do have x's on both sides, and I do have numbers on both sides. So let's move all my letters to the left-hand side. So as it says negative 9x, I'm going to do the opposite, which is to add 9x. And look where I'm lining it up. I'm not putting it at the start like I did last time. I want them lining up with my other x's. Be careful as you're doing this. If you look at this, you might just say x plus 9x and get 10x, when actually it's negative 1x plus 9x. So another time where you might need a calculator if your work on negative numbers is not so good. As it was 8x, I put positive 8x here because I don't really want there to be nothing between these two things. Otherwise, I might think it's 1 times my 8x. And then bring that 9 down as well. Probably do a slightly better job of lining up equal signs here as well. There we go. Now I've got my 8x, I want to move terms away from the 8x. So move the 1 to the other side. So as it's a positive 1, you can subtract 1. And 9 take away 1 is 8. Divide both sides by 8, and you'd finish up with 1. If you are interested in checking your answers, just remember you just substitute back up here. So 1 take away 1 is 0, and 9 minus 9 times 1, as in 9 minus 9, is also 0. As you've got 0 equals 0, as that's a true statement, you know that this answer must be correct. If you had an incorrect answer, say 2, if I plug 2 into here, I would get negative 1. And if I plug 2 into here, I would get negative 9. And as negative 1 does not equal negative 9, I know I've made a mistake, which means that 2 is not the answer. So true statement means that this answer is correct. An incorrect statement means that this answer is incorrect as well. Okay, let's head on to our last example. So, same sort of thing. I put the letters in the middle again here. So I'm going to be moving all my letters to one side. So I personally want to collect on my left-hand side. So instead of adding 3f, I'm just going to take away 3f from both sides. And 5 take away 3 is 2. Once again, positive 2. So I'm just going to leave it like this. I'm going to move my 4 to the other side. So take away 4. Because I'm trying to move things away from my f. 7 take away 4 is 3. And then divide both sides by 2. And 3 divided by 2, let's not put 1.5. Let's keep it as a fraction. Check if it simplifies. This one doesn't, so we're just going to leave it as 3 over 2. And try not to change it into a mixed number either. We don't really want 1 and 1/2. We want to leave it as an improper fraction. And that's going to be important when we do our questions on a future unit when we do slope. Because we use something called rise over run, so we need that top number and that bottom number specifically. So a good habit to get into earlier. If they want it as a decimal, they will tell you that in the question anyway. But otherwise, you should leave it as a fraction. Now, at this point, this is where we would actually be trying to practice our questions. I've put the answers alongside here because still right now, if we're making mistakes, we want to try and find out quickly at where we made those mistakes. So if you're not getting 4 for number 1, if you were in class, you'd obviously ask the teacher. If you're at home, you might just want to use office hours or stay after. I've put for the assignment, try 1 through 10. If you're finding those easy, you should certainly try 11, 12, and 13 as well. What you'll notice is, to begin with, I've started with nice numbers. I got a negative at the end here, but that's still an integer value. And then for 11, 12, and 13, we've started to get into fractions, which is the same method as you saw from my last example. But it's just going to be possibly that little more complicated as you're doing this. Just a reminder, every question you must show your steps right now. You can't just write down the answer, like you can't just write down question 1 is 4. I want to know why is it 4, and what I mean by that is this. So write out the question, show me the opposites, and then every question should look like this. Once you've written the question, there should be 1 opposite, 2 opposites, 3 opposites, and that's why this is a 3-step equation. At the very end of the lesson, I would also talk about some special cases when you do 3-step equations. So kind of linking back to what we did in the warm-up as well, our distributive property. So if I have parentheses, and this is kind of going to link into our next lesson when we add in extra steps. 4 times 3x, 4 times 6, 3 times 4x, 3 times 8. And then once I've got variables on both sides, I can start to bring them to the left. Now, the thing you might not notice straight away, but I'm used to seeing this, is notice the number of x's here is the same. If I go back to my 3 examples, that was not true anywhere. I had 5 and 3. I had -1 and -9. And I had +5 and +3. So that's what makes this question a special case. So we know something strange is going on here. And when you take away 12x from both sides, not only does it cancel here, it actually cancels here as well. So you get 24 equals 24. Now you could try subtracting 24 from both sides and you'd end up with 0 equals 0 as well. But basically what you're going to do is, does 24 equal 24? Yes, it does. That means there's actually an infinite number of solutions for this question. What that means is any value of x that you substitute into here would be a correct answer. So if you plugged in 0, 3 times 0 plus 6 is 6, 4 times 6 is 24. 4 times 0 is 0, plus 8 is 8. 3 times 8 is also 24, so that works. If you try 1, 3 times 1 plus 6 is 9, times by 4 is 36. 4 times 1 is 4, plus 8 is 12, and 3 times 12 is also 36. So actually any number in the world would actually work for this. That's why we call it infinite solutions. Basically because these two things are the same. They're just written differently. They both said 12x plus 24. So we could actually have stopped at this line here if necessary. But normally we would cancel out the x's and just get a number equals a number. The other type of question, which is similar as well, this time just one set of parentheses. 3 times 2x is 6x. 3 times 1 is 3. Notice I have x's on both sides, and notice again I have the same number of x's, so we know it's that special case. So if I take away 6x from both sides, I get 3 equals 5. Now this time, clearly 3 does not equal 5. So that's how I normally ask the question. Does 3 equal 5? No. Therefore, the answer to this question is no solution. There isn't a single x value you can use for this question that would actually give us a true statement, because 3 does not equal 5. If it was 3 equals 3, then I would have said yes, it does, and I would have put that infinite solutions. So keep an eye out for those questions as well. When we have the same number of x's on both sides, it's either going to be no solution or infinite solution, depending on if they're exactly the same, infinite solutions. If they have the same number of x's but have different constant terms, we're going to put no solution. There was the summary that goes with it. I've put the two questions side by side just so you can see. And this gives us a kind of an introduction on what our future lesson is going to look like as well. Not only are we going to be bringing x's to one side, we're also going to be distributing and putting all those key skills together from the last few lessons. Make sure, importantly, you go back to these questions. Get used to that idea of bringing all your variables to one side, all your numbers to the other side. And that should do it for this lesson. I think that's pretty thorough. Go check out the rest of the YouTube page if you need help on some of the previous units, and that will do it for this video, though.